This is a tutorial on properties of real numbers and simplifying expressions. The first property of real numbers we're going to talk about is the commutative property. The commutative property only works for addition and multiplication. But the way to remember the commutative property is if you think of people or numbers as a community, then it doesn't matter what order they appear in or who hangs out with who. So let's talk about this. If I had 1 and I added 4, I would get 5. And if I had 4 and I added 1, I would also get 5. So with addition, it doesn't matter what order they appear, you'll always get 5. So if I have a plus b, and that's equal to c, then I could also write this as b plus a, because I'm still going to get c. Same thing happens for multiplication. If I have a 3 and I multiply it by 5, I get 15. But if I have a 5 and I multiply it by 3, I'm still going to get 15. So again, it doesn't matter what order they appear with multiplication. So a times b is equal to c, or I could say b times a is also equal to c. Now it's important to remember that the commutative property only works for addition and multiplication. It does not work for subtraction and division. And let's see why. Here I have 4 minus 1 is equal to 3. But if I have 1 minus 4, that ends up equaling negative 3. And these are not the same answer. So the order in which our numbers appear changes the answer. Again, with division, if I have 8 divided by 2, that's equal to 4. But if I have 2 divided by 8, that's equal to 1/4. So again, the order that we do our operation affects the answer. So the commutative property does not work for subtraction and division. Now if you have a subtraction or a division problem and you really need to reorder the numbers, there is a way to go about doing this. First, if you have a subtraction problem, you have to turn it into an addition problem. And the way to do that, if I had 4 minus 1 is equal to 3, I change this minus 1 into adding a negative number. So the 4 minus 1 turns into a 4 plus a negative 1. And now that this is an addition problem, the commutative property works again. If I have 4 plus negative 1, I get 3. And if I have negative 1 plus 4, I still get a 3. So if you have a subtraction problem and you need to rearrange your numbers, you need to turn this subtraction problem into an addition problem by simply adding the negative. Now if you have a division problem and you need to rearrange your numbers, there's another way of doing it. Here I have 8 divided by 2 and that's equal to 4. Now if I wanted to rearrange the 8 and 2 without changing my expression's value, or the 4, I would first turn these into fractions. So I have 8 over 1 divided by 2 over 1, and that's equal to 4. But remember, if you're dividing by a fraction, you can also multiply by the reciprocal. So 8 over 1 divided by 2 over 1 is the same as writing 8 over 1 times 1/2. And 8 over 1 times 1/2 is equal to 4. Well, now that this is a multiplication problem, the commutative property works again. So I could rewrite this as 1/2 times 8, and that's equal to 4. So if you have a division problem, and you need to rearrange your terms or your numbers, you need to turn this division problem into multiplying by the reciprocal of your divisor. The next property of real numbers we're going to talk about is the associative property. Again, the associative property only works for addition and multiplication. And the associative property means it doesn't matter which numbers kind of hang out with each other. And let's see how this works. Here we have 4 plus 5 plus 2. Well, 4 plus 5 is 9. And then we add 2, that's 11. But if I wanted to, I could put the 5 and 2 together, and 5 plus 2 would be 7, and then 4 plus 7 is still equal to 11. So it doesn't matter if I group or associate what number with what. So I can put A and B together, and then add C and get a D. Or I can put B and C together, and then add A, and I would still get D. Same thing works for multiplication. Here I have 2 times 4, and that's equal to 8. And then if I multiply it by 5, I get 40. Or I can do the 4 and 5 together first. 4 times 5 is 20, and I can multiply that by 2, and I still get 40. So it doesn't matter if I group the A and B together or the B and C together. A times B times C is D, or I can do B times C and then multiply the A, and I'm still going to get D. Now you have to remember that the associative property only works for addition and multiplication. It does not work for subtraction and division. And here's why. If I do 10 minus 5, I get 5. And then I subtract 4, I'm going to get 1. But if I do the 5 and 4 first, if I do 5 minus 4, that's 1. And then 10 minus 1 is equal to 9. So the order I did this in changes the answer from 1 to 9. This happens with division too. Here I have 12 divided by 6. Well, that's 2. And then if I divide 2 again, I get a 1. But if I do the 6 and 2 first, 6 divided by 2 is 3. And then 12 divided by 3 is equal to 4. So the order I did my division changes my answer. Now again, if you have to rearrange a subtraction problem or a division problem, there's a similar way, like the commutative property, to go about it. For a subtraction problem, again, you're just going to add the negative. So 10 minus 5 and then minus 4 would turn into 10 plus negative 5 and then plus negative 4. Because 10 plus a negative 5 is 5. And then if I add a negative 4 again, I get 1. Now this is an addition problem. It doesn't matter which ones I do in what order. So if I have negative 5 plus a negative 4, this is a negative 9. And then 10 plus the negative 9 is still equal to 1. So if you have a subtraction problem and you need to rearrange or regroup your numbers, you need to turn your subtraction into adding a negative. Similarly with division, if I have 12 divided by 6 and divided by 2, and I need to regroup these, instead of dividing by 6, I'm going to multiply by the reciprocal. So instead I'd have 12 over 1 times 1/6 and then times 1/2. Well, 12 over 1 times 1/6 is equal to 12 over 6, which is 2. And then if I multiply by that 1/2, I'm going to get 1. Well, I can regroup this now that it's a multiplication problem. 1/6 times 1/2 is 1/12. And if I multiply that by the 12, I still get 1. So if you need to regroup or rearrange a division problem, change this divisor into multiplying by its reciprocal. And then the associative property will still work. The last property of real numbers we're going to talk about is the distributive property. And the distributive property comes into play whenever you have a multiplication or a division next to something in parentheses. So if you have A times the quantity B plus C, or A times the quantity B minus C, or A divided by B plus C, you can use the distributive property. And we'll see how it works. Here I have 5 times 3 plus 2 in parentheses. Well, I do the parentheses first, and I'll get 5, because 3 plus 2 is 5, and then I multiply it by 5, and I'll end up with a 25. Well, what if for some reason I didn't want to do it that way? I could take this 5, and since this is a multiplication, I can multiply the 5 with everything that's inside the parentheses. So 5 times 3 plus 5 times 2. Well, 5 times 3 is 15, and 5 times 2 is 10, so that still equals 25. This works for division too. Say I had 6 plus 4 divided by 2. I could add what's in the parentheses first, which is come to 10, and then divide it by 2 and I'll get 5. But if I wanted to, I could take this divided by 2 inside the parentheses by dividing everything in the parentheses by 2. So I ended up with 6 divided by 2 and 4 divided by 2, and then I would add those together. Well, 6 divided by 2 is 3, and 4 divided by 2 is 2. So again, I would still equal 5. The next thing we're going to talk about is the order of operations. Say you were given an expression that had lots of different operations in it. We have a subtraction, we have a multiplication, we have a power, an addition, and another multiplication. How will we know which one to do first? We saw from our properties that sometimes negatives and dividing things can change our answer if we do it in the wrong order. So let's develop an order and stick to it so we always get the right answer. Well, the first thing you're going to do is you're going to do any operation that's in any grouping symbol, like parentheses or absolute values or brackets or anything like that. Always do what's inside those first. Then after that, do all your exponents and roots. Next, you're going to do all the multiplication and division, and then lastly, any addition or subtraction. Now, if you can't remember this order of operations, there's an acronym to help you, and it's called PERMOAS. If you want to say that, PERMOAS. Some people use PEMDAS, but it's really the same thing. And this is where P stands for parentheses, E for exponents, R for roots, M for multiplication, D for division, A for addition, and S for subtraction. So if you can remember PERMOAS, that means you always do parentheses first, then exponents, then roots, then multiplication, and so on. So let's try using this. Here we're given a couple expressions, and we're going to use our order of operations to solve them. So our order of operations is PERMOAS. So first we're going to do whatever's in parentheses. Well, here we have a parentheses 5 times 4. So if we do that first, we'll get 1,000 minus, and then 5 times 4 is 20. So 20 squared plus 10 times 50. Well, now that we've done all our parentheses, or all of our grouping, next we do exponents. Well, we have an exponent of 2 here, so we'll do that next. And we're going to get 1,000 minus, now 20 squared is 400 plus the 10 times the 50. Well, we're done with our exponents, so now we got to do roots, except we don't have any roots, so we can skip that one. Next is multiplication, and here we have 10 times 50, so we'll end up with 1,000 minus 400 plus 10 times 50 is 500. So we're done with our multiplication. Next you would do division, but we don't have any in this expression. So next you do addition. So 400 and 500. So we'd get 1,000 minus 400 plus 500 is 900. And then lastly we have subtraction. 1,000 minus 900 is 100. Let's try this again. Here we have our order of operations. And the first thing we do is parentheses. Well, it's not just parentheses, it's any grouping term. So that includes our absolute value and what's underneath the radical. If it helps, think of an absolute value as the absolute value of 20 minus 50 in parentheses, and then subtracting the cube root of, in parentheses, 140 minus 15. Radicals and absolute values and brackets are all grouping terms, so they all fall under the parentheses of PERMOAS. Or if you remember your order of operations, you just do all grouping terms first. So 20 minus 50 is a negative 30, and that's in the absolute value sign. So the absolute value of negative 30 is a positive 30. And we're going to subtract the cubed root of 140 minus 15. Well, that's 125. So the cube root of 125. So now we're done with our grouping terms. So we'll do our exponents next. We don't have any exponents, so we can skip that one. Next comes the roots. We have a cubed root here, And the cubed root of 125 is just 5. So we end up with 30 minus 5. Next we call multiplication and division, but we don't have any in this expression. Next will become addition. Again, we don't have any. So then lastly is subtraction. So 30 minus 5 would be 25. Now the last thing we're going to do is simplifying expressions. And we're going to have to use our order of operations and all of our real number properties to simplify an expression. Now there's some terms that we need to talk about before we can simplify an expression. And the first term, unfortunately, is term. A term is anything that's separated by a plus or minus sign. So 10z is a term, 14x is a term, 3x squared is a term, 5 times x plus z is a term, negative 2x is a term, and 5 is a term. Now we're going to talk about like terms. Like terms are just terms that have the same variable and that variable has the same exponent. So our like terms here would be 14x and 2x because they have the same variable and the same power, so they're like terms. A constant is any term that doesn't have a variable in it. So our constant in this expression is the 5. And then coefficients are the number that variables are multiplied by. So in our first term, 10z, our coefficient would be 10. In 14x, our coefficient is 14. Negative 3x squared, or minus 3x squared, our coefficient is a negative 3. Our coefficient for the 2x is a negative 2, and so on. So let's take what we've learned and see if we can simplify these two expressions. Here we have a 10z plus 14x minus 3x squared minus 5 times x plus z plus a 5. Now, order of operations, you always do parentheses first. And here we have a parentheses term. So we're going to use the distributive property to move this negative 5 inside our parentheses. So what we're going to get is 10z plus 14x minus a 3x squared minus 5x minus 5z plus 5. Now the reason why we have a 5z here is try to think of this as a plus negative 5 times x plus z. So this negative 5 would go in and get multiplied by both the x and z. Now I'm going to use the commutative property to rearrange our terms and put our like terms next to each other. And when you do this, you typically put your higher power terms first. So I'm going to rewrite this as a negative 3x squared plus 14x minus 5x plus a 10z minus a 5z plus 5. Now that we've written this with our like terms together, you can add the coefficients of the like terms. So this would be negative 3x squared, and then 14 minus 5 would be a plus 9x, and then 10z minus 5z would be a positive 5z, and then plus 5. Now we can't combine any more like terms, so this is our simplified expression. Now the reason why I was able to add coefficients is because imagine this 14x minus 5x. Imagine if we did the distributive property in reverse, and I took out the x. I would get x times 14 minus 5. Well, 14 minus 5 would be 9, so I'd have 9 times x, so that's where the 9x comes from. But you don't usually want to do all those steps, so if you can remember this, you can always just add your coefficients as long as you have like terms, or terms with the same variable and the same power. So here's our simplified expression, 3x squared plus 9x plus 5z plus 5. Let's try the next one. Here we have a 4x plus 7 plus 7x squared. So first I'm going to use the distributive property and move this 4 inside. So I'm going to get 4x plus 28 plus a 7x squared. And then typically you always write the first power first, or the highest power first. So I'm going to rearrange this using the commutative property, and I'm going to get 7x squared plus 4x plus 28. So here's our simplified expression. I have no more like terms, so I can't combine anymore. So that's our answer. And that completes the tutorial on properties of real numbers and simplifying expressions.